Okay, so solving simultaneous equations, we've got a quadratic equation here and a linear equation here. So this will be a curve, a parabola, this will be a straight line. And to solve them, what we're looking for an x and y values that are consistent with both equations, that will work in both equations. So if I find a value of x and y that works in this equation, it will also work in that equation there. So what I'll do is I'll label them 1 and 2, okay? And to solve them simultaneously, okay, quite simply, going back to what I said a moment ago, if the x and y values work for both equations, then the x and y values will be the same, won't they? Okay, for both equations, and more importantly, in this case here, the y's will be the same, won't they? Okay, so if the y's are the same, then I can essentially say that x squared plus 2x plus 4 is equal to 4x plus 7, because the y's will be the same, won't they? They'll have the same value. So in other words, this here will equal the same value as 4x plus 7. So I can say they're equal. I can get everything onto one side. Okay, put it equals to 0. If I simplify that, then I get x squared minus 2x minus 3 equals to 0. And I've got myself then a quadratic here then which I can solve. And if I get the solutions out, I'll then have the values where they are consistent for both equations. So in this case then, you put x in both brackets. Now you need two values that multiply to give minus 3. And add up to give, so minus 3, that add up to give minus 2. So two values are, if you think about it, a 3 and 1. Okay, and it'll be minus 3 plus 1. So that means then two brackets multiplied equal to 0. So either the first one is 0 or the second one is 0. So that means then x will equal minus 1 or x will equal to 3. Okay, now those are my x values. I then need to work out my y values. So if I sub this in then back into one of these equations, doesn't matter which one. In fact, I'll choose number 2 because that one looks a lot easier, doesn't it? So sub into equation 2. So when x is equal to minus 1, the first result here, y then will equal, let's sub it in, to 4 times minus 1 plus 7. So if you work that out, you get a 3. And then when x is equal to 3, we'll sub that in as well. Y will equal to 4 times 3 plus 7, and that comes out to be 19. So my 2 points are minus 1, 3, and 3, 19. Now in the question, it did say, didn't it? It did say interpret your results geometrically. So what's going on here? Well, these two results here, these two coordinates, is quite simply where the curve and the line intersect. Okay, so these represent where the curve and the line intersect. Okay, so if I was to draw a quick sketch of it, I mean, I don't even need a ruler such to draw an axis, just so you can understand the situation. You've got essentially a parabola and a straight line like this, and there's 2 points here where they intersect, one there and one here. So it would intersect that point and this point here. Okay, so it's, we've essentially found 2 points where both equations are consistent. Those two sets of coordinates here will work in the two equations that are given in the question. Okay, so we've solved where the curve and the line intersect.